Sauce here. This is a video lesson on trig and multiple solutions. Let's work with an equation. The sine of theta is equal to 1/2. And we wanted to find the solutions to this equation, the angle whose sine is 1/2. We're going to approach it by graphing the two sides of this equation. And we're going to find solutions at intersections of the graph of sine theta and the graph of 1/2. The graph of sine is periodic, the period of 2 pi. It reaches a maximum of 1 and it has a minimum of -1. Sine starts at the origin and reaches its maximum at pi over 2. Then it comes back down to intersect the horizontal axis at pi and completes a period at 2 pi and is periodic or cyclic, so it continues in both directions forever. The graph of 1/2 is very simply the constant function at 1/2. And we can find solutions to this equation when they're equal. The solutions are going to be at intersections. So here the graph of sine and the graph of 1/2 intersect. What is the horizontal value at that point of intersection? Well, we could find it by solving for theta. We're looking for the inverse sine of 1/2. I got theta by itself by undoing sine with inverse sine. We could use a unit circle to get a better understanding of what angle has a sine of 1/2. A unit circle has a radius of 1. And we're looking for the angle whose y value is 1/2, or the height of this point. And if we drew the unit circle to line up with its graph, then the 1/2 value here is approximately the y value of this point. We're looking for this angle theta. A calculator would give us pi over 6, a single answer. We could key in the inverse sine of 1/2, a calculator would show us pi over 6, or the decimal equivalent. But we can see from this graph that there is a second intersection, which means that there is a second angle that has a sine of 1/2. And on the unit circle, we're familiar with another point associated with an angle in the second quadrant that has the same y value, or the same sine of 1/2. We can find that second angle in the unit circle by taking a half a circle, or pi, and subtracting theta, which is pi over 6, to get 5 pi over 6. The x-coordinate of this second point of intersection is at 5 pi over 6. And so we know that within a circle, theta is pi over 6 and 5 pi over 6, which is better than what a calculator would give, just the single answer. But a complete answer takes into account that this graph continues in both directions, keeps going up and down to both positive infinity and negative infinity, and this line would intersect all of those waves to create an infinite number of angles whose sine is 1/2. That's equivalent to adding or subtracting full circles to these angles to get additional angles that have a sine of 1/2. So how do we express the complete answer? Theta is the two angles that can be found within the circle plus full circles, or 2 pi n, where n is an integer. And because integers can be negative, then that takes care of also subtracting full circles, which is all of the intersections to the left on this graph.